This video will represent an introduction to how one would go about balancing chemical reactions. In order to be able to write a balanced chemical reaction, we first have to know what the reactants and products are and be able to write their chemical formulas. In this particular reaction, we're going to look at the combustion of methane, in which the reaction involves the reaction of methane, CH4 with O2. The products of this reaction are going to be carbon dioxide and water. In order to balance this reaction, we have to place coefficients in front of the formulas so that we have the same number of each of the atoms on both sides of the arrow. So in this case, we typically, for a combustion reaction, would start with carbon. And so in this case, we notice that we have one carbon in the methane and one carbon in the CO2. And so in fact, putting a coefficient of 1 in front of those two formulas gives us a balance for carbon. The next element of interest would be hydrogen. So in this case, we now notice that we have 4 hydrogens in the methane molecule, but on the right-hand side, there are only 2 hydrogens for the water. To get that to be balanced, we put a 2 in front of the water. At this point, now we have 4 hydrogens on both sides of the arrow. Finally, we turn our attention to oxygen. Typically, at this stage, we would look at the number of oxygens on the product side. You see that there are 2 oxygens in the carbon dioxide and 1 oxygen in the water, but times 2 because of the coefficient. And so we have a total of 4 oxygens on the product side. To get there to be 4 oxygens on the reactant side, we put a 2 in front of the O2 molecule. At this point, we have a balanced chemical reaction, and this would correspond to the molecular diagram that you see on the right, in which the methane molecule is represented up at the top. The other reactant, O2, is represented by the grouping of the red balls that are connected together. And then the products are going to be on the bottom of the arrow, which is carbon dioxide and 2 water molecules. At this stage, then, we recognize that the typical convention for writing chemical reaction doesn't involve using 1s in front of the methane and the CO2, so we would typically drop those out of the reaction and write the formula as you see here. As an example of how to go about balancing a reaction and trying to make it as systematic as possible, we have a reaction here shown where we're going to take ammonium nitrate and have it decomposed into dinitrogen monoxide and water. The first step is to choose an element to balance first. Typically, we would choose an element that is contained within the fewest number of molecules on both the reactant and product side. In this case, it could be either nitrogen or hydrogen, so you choose one of those. In this case, we're going to balance nitrogen first. You see that on the reactant side, there are 2 nitrogens, and on the product side, there are also 2 nitrogens. So we put a 1 in front of each of the formulas, and this balances the nitrogen. The next element then to balance would be the hydrogen. There are 4 hydrogens on the reactant side. To get there to be 4 hydrogens on the product side, we would put a 2 in front of the water. Finally, we have to check to make sure that the oxygens are balanced, and at this stage then we see that there are a total of 3 oxygens on the reactant side, and then also there are 3 oxygens on the product side, 1 in the N2O, and then for the water there are 2 of the water molecules. Finally, we need to take and make sure that we have the lowest whole number ratio for all of the reactants and products, and in fact in this case we do. As another example, we are going to examine balancing the reaction between magnesium nitride and water, which produces ammonia and magnesium hydroxide. As before, we need to choose an element that appears in the fewest number of compounds. In this case, we could use either magnesium, nitrogen, or possibly oxygen. And so from that, then we have to adjust the coefficients for the element we choose. If we decide to start with magnesium, we want to choose the element that has the largest number associated with it. In this case, magnesium is a good choice. So we see that there are 3 magnesiums in the magnesium nitride. So we would put a 3 in front of the magnesium hydroxide product. Then we need to choose the next element, could be nitrogen. And so in this case, there are 2 nitrogens in the magnesium nitride, and we would then place a 2 in front of the ammonia. At this stage, then, we would go to the hydrogen, and so we put 6 in front of the water to get a total of 12 hydrogens on that side, because there were a total of the 2 times the H in the magnesium hydroxide for a total of 2 hydrogens per that molecule. But then there was that coefficient of 3, so there were 6 hydrogens in the magnesium hydroxide, and there were an additional 6 hydrogens in the ammonia. So that gives us a total of 12 hydrogens on both sides of the reaction. At this point, then, we would check the oxygens. There were 6 oxygens in the water, and indeed 2 times the hydroxides in the magnesium hydroxide. So 2 times the O in the hydroxide times the 3 gives us a total of 6 oxygens on the product side as well. So at this point, you want to make sure that you have the lowest whole number ratio, and indeed at this point we have a balanced chemical reaction. As an example of balancing a slightly more complex reaction, in this case we're going to do the complete combustion of ethane with oxygen to produce CO2 and water. And so in this case, typically we would start with either the carbon or the hydrogen. Carbon is a fairly typical first choice. So in this case, we see that we have 2 carbons in the ethane, and so we would then go ahead and put a 1 in front of that and a 2 in front of the carbon dioxide. That balances the carbons. At this stage, you go to the hydrogens. You see that there are 6 hydrogens in ethane, and since we put a coefficient of 1, that would give us a total of 6 hydrogens on the reactant side. The only place there is hydrogen on the product side is in water, so we would put a 3 in front of the water. At this stage, now we're going to turn our attention to the oxygens, and taking a look at the product side, we see that there are 2 times the 2 oxygens in carbon dioxide. That's 4. And now we have 3 times the oxygen in the water, so that's a total of 7. Unfortunately, on the reactant side, the only compound that has oxygen in it is the elemental oxygen, which is O2, and that's an even number of oxygens on the reactant side. So we have a situation where we have an odd number of oxygens on the product, but an even number on the reactant side. This then requires that we do a little bit of fractional work at this stage, and we see that if we dealt with a fraction of 7 halves times 2, that would give us our 7 oxygens on the reactant side. However, you can't have fractions in a balanced chemical reaction. we need whole numbers. So to get rid of that fraction, what we should do is multiply all of our coefficients by 2. And so at this stage, then, we would double all of our coefficients, and this then will give us our balanced chemical reaction involving 2 ethane molecules, 7 oxygens or 7 O2s, 4 CO2s, and 6 waters. Now, to kind of summarize the aspects of chemical equations that we want to point out here, whenever you have a chemical reaction, you have both the reactants and the products. You have the chemical formulas associated with various species. This tells us the number of atoms in the overall formula. But then also we will have stoichiometric coefficients. These tell us about the number of molecules or ions that might be present. These are essentially multiplication factors. And then in addition to that, we assume that if there is no number in front of a formula, that stoichiometric coefficient must be 1. In addition to that, we also have additional information associated with the phase of the various species. These appear as letters that are in parentheses just to the right of each of the formulas. In addition, whenever we have ions, we have to make sure that we have the charges of the various ions, and we also have to notice that in this case then the amount of charge present on both the reactants and the product side, just like the number of atoms on the reactants and product side, they have to equal one another. So basically what it comes down to is a balanced chemical reaction is similar to a mathematical formula in that we have to have an equal number of each of the atoms on both sides of the arrow. We also have to have an equal amount of charge on both sides of the arrow. So in other words, whatever you do on one side, you have to do the same thing on the other.